Hello, everyone. I hope you're doing great. My name is Ali, and today I'm here to explain how the Mish program works so far. So, as you can see, we can create a new terminal, and we can run make. Make file is already created in this folder, and if you press make, it would compile all the files that you have in this folder, and we can do make, and everything is compiled. Perfect. Next up, we can run the program with typing /mesh, and the program opens. So the program is now open, and we have some options such as variable assignment and reassignment. For example, we can say x equals 5, and then we can print x. As you can see, x is 5, so the variable of x would be displayed. Or we can say y equals 3, and we can print y, and here you go. And also we can reassign variable, meaning that y equals 3 now, we can say y equals 7. And then once we print y, 7 is displayed. So the code that do the storage handling is this variables.c or variables.h. So there was two approaches to this problem. The first one was using a linked list, and there was two approaches to the storage problem. One of them was using a linked list, and another one was dynamically resizing and reshaping an array. Once it's full, we have to make another array with new size and copy everything into it, which I found it a bit complicated, and I found a linked list kind of simple and easy to understand. So I went with the linked list part. Yeah, so as you can see, our linked list has a couple of elements. One of them is a struct. Each struct represent a node in a linked list, and we have a variable called head, which points at the beginning of the linked list. We have four methods or functions, and the first one is a variable insert, which inserts a variable into, or a node into, the end of the linked list. And another function we have is search, which goes on and search and tries to find the given variable name. The other two are freeing the variables, freeing the nodes from the memory. If you look at the code for the variable insert, we have a couple of parts. So the first part is, first we create a current, which is equals to head, and if current is null or if head is null, then we would make a node and assign everything to the node, and we make it the first index, and we put head equals the new node. Otherwise, if there were one or more nodes in the linked list, we make a while loop, and we iterate through the linked list until we reach the lam index. However, in between, if the given variable name to us is equal to an existing variable name already in the linked list, these two if statements would find it and would replace its value, meaning freeing the old value from the memory and reassigning the new value to it. And this if statement is if that existing variable was at the last index of the linked list. If none of these conditions worked and we are at the end of the linked list and there were no variable reassignment, then we create a new node and we append it to the end of the linked list. For variable search, we just iterate through the linked list, and if the variable name with the same given name was found, then we return its value. If nothing was found, we return a null. For free variables, once we are done with the program, once we exit, to avoid memory leaks, we have to free all the nodes from the memory. So this is the main function that we call, and this is the helper, which is a recursive helper and goes through each node. Once it's reached the last node, it starts freeing and comes back to the previous node and free and free. Next, let's talk about a variable expansion. So as you might seen, I use the $sign to represent variable in the Mish program. Once we are using a dollar sign in any part of the command, no matter where, the variable after the dollar sign is expanded and its value is replaced with the dollar sign and the variable name. For example, if we assign x equals 10 and we do echo dollar sign x, we would see 10. And as you can see, 10 is replaced with dollar sign and x. We can also print multiple variables at the same time. For example, y was assigned to 7 and now we have x assigned to 10. So we can say dollar sign x and dollar sign y, and we can see it's 10 and 7. We can also use this variable expansion while we are making a new variable. For example, we say z equals dollar sign y, and this basically expands the y, and once we expand the y, we have 7, and 7 is assigned to z. As you can see, if we do equal dollar sign z, we get 7, meaning z was equals to y, which was equals to 7. So the code that handles this process is in the io_helpers.c, and which is tokenized input. So after record, this code is not perfect, and I figure out that there are some bugs existing in this implementation, and I may have to replace the code with something else. However, the idea would stay the same, and the approach is that first we tokenize the input characters based on space and tab. So after the input is tokenized and put it in a temporary array based on tab and space, the second idea comes in, which is go through each index of the temporary array, and if in each index there was a dollar sign following by a variable name, we call the var search that we created in the variables.c, and we replace the dollar sign and the variable name with the value given by var search. Or in another word, we replace each dollar sign and variable name with its value. However, this code again is not perfect and I have to change it. But in this code, as we can see, there are 2 steps to do this. The first step is the edge case, meaning if the token count was 1 and there was an equal sign in the token and the equal sign was followed by a dollar sign, this means that this is a variable assignment in which the value assigned is the variable expansion. Then we have to handle this differently. And if it wasn't a variable assignment, then we go through each token and replace the dollar sign and variable name with its value. Another rule for this program is that the max input string is 128 characters. And if it exceeds that, the program can't handle the command. As you can see, we have a definition of max string length, which is 128, and is checked over here in the io_helpers.c. There is a function called getInput, and it is called for getting the input from user. And if the input length is bigger than max string length, then we would get an error. So this is the error handling of strings with length more than 128 characters. Thank you so much for watching and have a great day.